When we're trying to solve a quadratic equation with three terms, we're trying to figure out which method is the best to use. Is it the factoring method? Is it the completion of the square method? Or is it the quadratic formula method? So you're going to see I'm going to solve both of these examples using three different ways, three different methods available, and you're going to see how these three methods relate and which one serves as a great alternative to the other when one of them may not work. So let's take a look at the first example. X squared minus 3x plus 1. If we try to factor this, we're trying to find the factors of 1 that sum up to negative 3. We know the factors of 1 are going to be only 1 and 1. 1, 1, or negative 1, negative 1. In either case, when you try to sum them up, 1 plus 1 is equal to 2, which is not equal to negative 3, right? Because that's the sum that we're looking for. So that's not equal to negative 3. If you try to sum up negative 1 and negative 1, you're gonna say negative 1 minus 1, that's negative 2. And again, that does not equal to negative 3. So what does that tell you? That this is not solvable by using the factoring method. Okay, so not factorable. Okay, so if this is not factorable, you're going to have to use another method like completion of the square or the quadratic formula. Now I'm going to tell you this: the quadratic formula will work regardless of whether, regardless of the type of the example of the quadratic equation that you have, right? If you have three terms in the quadratic equation, that's it. Quadratic formula, that's the word that comes from it, right? Quadratic formula, right? It will help you solve a quadratic equation like this. So whichever equation you have, the quadratic will always solve it as long as there is a solution, okay? But factoring, as you can see, does not it looks like there's no solution, but that's not true. It just says that it's not factorable, right? Because there are no factors of 1 or negative 1 that sum up to negative 3. But it doesn't mean there's no solution. Okay, so I'm just going to say this. Does not mean there is no solution, right? So this is very important. So now let's take a look at completion of the square. So completion of the square is pretty straightforward. You have to copy down the first two terms, and then you have to add the third term, which is going to be 1/2 of the coefficient of x, so divided by 2, the negative 3, squared. Okay, so that's what you're going to add on both sides. So that means 0, and again plus what you added. And why do you do it on both sides? Because whatever you do on one side of the equation, the rule of the equation says you have to do the same thing on the other. Otherwise, you will violate the equation. You will have created a different quantity, right? And you don't want to do that. You want to keep the same quantity, right? And to do that, you have to do whatever you do on one side, you have to do on the other. So now, what do? We have to actually subtract 1 because we're not going to need it. The beautiful part about this trinomial is that when we complete the square, we will express it as a binomial being squared. I'm going to show you how that's done. So now that we have that, we're going to have x squared minus 3x plus negative 3 over 2 squared is equal to, now I purposely leave this as negative 3 over 2 squared. I don't want to write it as 9 over 4 yet, and I'm going to explain to you why. So that's equal to 9 over 4 minus 1, right? 9 over 4 minus 1. Okay. So now you realize that we need this part. We need this negative 3 over 2. We need this negative 3 over 2 being squared because we're going to use that as a reference. Because now we can say that we can create a binomial squared. The binomial is going to be x minus 3 over 2, right? So what you're going to do is, you notice that there's a minus 3 over 2, so you just write x, and then directly minus 3 over 2 here. You close the parentheses, you square it, and there goes your perfect square binomial. right? And this perfect square binomial actually, well, it actually turns into a trinomial that is a perfect square, but it can be expressed as a binomial being squared, right? So not necessarily perfect square binomial, I phrased it wrong. A binomial that is being squared is a perfect square trinomial, okay? Because when you carry out the square, you will expand it, you will make this to be x squared minus 3x plus negative 3 over 2 squared. Okay, so in any case, on the right side, this is equal to 9,4 minus 4,4, which is 5 over 4. Now, what you're going to do, you're going to square both sides, okay? So squaring both sides, and I'm not going to use another step for that, I'm just going to work it out here. You square both sides, so that means when you square both sides, you will have to write plus minus, remember that, and the square root of the right side as well. Why plus minus? Because when you square things back, you realize that the minus being squared is also positive, right, which is 5, 4. And positive square root of 5 over 4 is also positive, right, positive 5 over 4. So it's very important to write plus minus. Don't ever forget that. Some students forget to write plus minus. And remember, plus minus suggests that there are two solutions, which is consistent with the fact that this is a quadratic polynomial. Quadratic means that the leading degree term with the highest degree is 2, so that means there will be at least two solutions, no less than that. Unless of course, the vertex of the polynomial in question or parabola is at the origin, or there is no solution, right? It doesn't touch the x-axis. But most of the time, plus minus guarantees that there can be two solutions, theoretically. So make sure you follow plus minus, always. So that means that theoretically, remember when you square root the square and the square root cancel each other out, right? So they're friends in a sense that way, right? So this 2 and the square root, they tell each other, you know what? As soon as that square root guy appeared, both of them are gone. So what happens is x minus 3 over 2 is by itself. X minus 3 over 2, let me write this a little better, is equal to plus minus. Now let's put radical 5 by itself, and radical 4 we know is equal to 2, right? So this is the answer. So that means x is equal to what? The first solution is radical 5 over 2 plus 3 over 2, right? So that means radical 5 plus 3 is essentially, because they have the same denominator in the end, divided by 2. And the other one is, of course, x. So I'm going to write x1. That's the first solution. The second one is going to be radical 5 minus radical 5, right? Because there's a minus. That's the second possibility for the second solution. Minus 5 plus 3 divided by 2. Okay? So now what I want to explain to you. So these are the solutions that we found. We found these solutions. And you might ask me, well, what is the relationship between this result and what we experience in not being able to factor? Well, this is the case. When you factor things, you realize that your solutions will be whole numbers or integers. You will never see a radical being present when you try to factor and find the solution. That's the very important aspect of not being able to factor. And as you can see, it didn't mean that there's no solution, right? We found a solution, but it had radicals in it. That's why we could not factor it. But not factoring it does not mean that there's no solution. It just means you can't factor it. When it's not factorable, it means that your solutions will most likely have a radical in them, or there will be no solutions, right? Either one of these two results can make it true that you cannot factor, all right? So now the quadratic formula, the beautiful formula that will always save you, right? It will always give you some type of solution unless there's no solution, right? If there's no solution, well, the quadratic formula will not give you a result. So we don't need to check the discriminant because we already know there are solutions. So we can use the quadratic formula directly. And as you know, the quadratic formula is this, minus b plus minus. Now take a look at this. Plus minus exists just like it did in the completion of the square method we've used, because it guarantees that it's going to be at least two solutions, possibly. Well, in this case, there will be two because we just showed. So plus minus. Now b squared minus 4ac under the square root, b squared minus 4ac divided by twice the value of a. Okay? So now let's take a look at this. What is the a value? The a value is going to be this guy, the 1. The 1, the coefficient of the x squared, the leading term coefficient is 1. That's the a value, right? That's 1. Now, the b value is going to be negative 3, right? That's that. This is the b value, negative 3. And the 1 will be the c value, as you might have guessed, because that's the only value available for the c. It's not going to be 0, right? Because 0 has nothing to do with the formula directly. We're not using a, b, or c for the 0. Unless there's no constant, right? If there's no constant in the end, then the c value is 0. But in this case, c is equal to 1. Okay, so what I'm saying is a, b, and c are all on the left side. When you write it in standard form, you try to solve a quadratic equation, a, b, and c are all on the left side, never on the right side. So this 0 on the right side, nothing to do with it. So now remember that I said that quadratic formula will produce a solution as long as the discriminant b squared minus 4ac is 0 or positive, right? So when it's negative, it's not going to work because the square root does not allow anything negative inside of it, right? It's not going to be a real solution when it's negative, right? It's going to be a complex number or imaginary numbers, right? No real solution, no real numbers allow a negative to be placed inside the square root. So when the discriminant b squared minus 4ac is 0 or positive, you will have a solution. When it's 0, that means plus minus does not matter, right? Because square root of 0 is 0. So that means there's only one solution. When the discriminant is positive, however, plus minus matters, right? Because this thing will be a quantity, right? Square root of positive is still some kind of quantity. So plus minus will matter. So that means you will have two solutions. So you see how this works? So now, let's try to solve for x using this formula. So x is equal to minus negative 3. Remember, we're negating the b, and the b had the negative 3 in it, plus minus. Now, b squared is negative 3 squared, so that's 9, minus 4 times 1, a, and then c is also 1, divided by twice the a. Twice the a is 2 times 1. So let's simplify this. So that's going to be 3 plus minus. Now we're going to have 9 minus 4, so that's 5 divided by 2. So you see we arrived at the same conclusion. Okay, so x1, the first solution, is 3 plus radical 5 over 2. And x2 is equal to 3 minus radical 5 over 2. And don't worry about the fact that the order of the terms contained in this solution is different from the order of the terms here. You realize that this one said radical 5 plus 3 over 2, but this is the same thing, 3 plus radical 5. Right? Addition is commutative, right? You can write addition terms in any order you wish. It's not going to change the quantity. So that's fine. We have no questions. These are the same solutions. So now, let's work out the second example. And as you will see, this example will be slightly different. It will have different results, and we'll explore how these three methods actually relate with respect to this example, the second example. So, factoring it now, we need factors of negative 30 that add up to 1, the middle guy, right? So factors of negative 30 that add up to the coefficient of x, 1, plus 1. So now what are they? What are the factors of negative 30? Let's see. Factors of negative 30, we have 1, negative 30, we have negative 1 and 30, we have 2 and negative 15. Notice how I go from the smallest one to the biggest one, speaking of absolute value, because that's easier, right? Because then you kind of press them both on both sides. You increase the first one, you decrease the second one, speaking of absolute values. And then it's easier, right, to catch the right pair that way. And because you're going to guess. If you're just going to do random stuff, you're going to guess, and you're going to run out of ideas sometimes. You're going to miss one. Sometimes you miss one and you spend more time. Right, so minus 2 and 15. And I'm alternating the signs. Remember that, because the negative 30 can be expressed as a positive and negative. and they can alternate, right? -1 with 30 and 1 and -30, both produce, these pairs produce a -30 when you multiply them. So now the next one is 3. Now let's actually stop there. Let's check whether the sum is equal to 1. Well, neither of them give you a sum of 1 yet, right? So let's keep going. 3 and -10, 10 and -3. And again, the sum is not equal to 1, so let's keep going. Now the next one is 5. Well, let's do -5 and 6. Is -5 plus 6 1? Yes, it is, right? So we found a pair. -5 plus 6 is indeed equal to 1. So that means the factoring is simple, right? You know this is going to be like this. And all you do now, you just write -5, the first one, the first factor, and then plus 6 for the second factor, and that's it. And then you're done. And then you found your factor, so that means each factor is set to 0, or x plus 6 is equal to 0. You add 5 on both sides. You subtract 6 on both sides, right? And what happens is you get x is equal to 5 and x is equal to -6. So, as you can see, when it's factorable, you only get integers, right? You do not get radicals whatsoever when the trinomial is factorable. But still, completion of the square works, and still the quadratic formula will work, right? So only the factoring may not work. Completion of the square will work unless there's no solution. And the quadratic formula will work unless there's no solution. But in this case, again, there is a solution, right? So let's keep going. Let's try completion of the square method in this example as well. So, completion of the square, let's follow the same algorithm that we've introduced in the first example. So x squared plus x. Now adding again, and this time let me use this color. So adding again, 1/2 of this being squared, right? So 1/2 being squared minus 30 is equal to 0. And again, plus 1/2 being squared. So what do we get? So as you can see, this will be the perfect square trinomial that we will need to convert into a binomial being squared, right? So we will have x squared plus x. And again, I'm keeping the 1/2 squared. I'm not making it 1/4 because we're going to need it. And also you want to add 30 on both sides because we don't need that -30 anymore for the trinomial. So that's going to be equal to 1/4 plus 30, right? So 1/4 plus 30. Okay, so now let's convert this guy into a binomial being squared, so that we know x, we just write x plus 1/2, right? Because we just needed this 1/2, right? Plus 1/2, we just need plus 1/2, and we just write it like that, and then square it outside because it's going to be a binomial being squared. And that is equal to 1/4 plus 30. 1/4 plus 30. The LCD is 4. So 120 over 4 plus 121 over 4. So that's so plus 1 over 4. That's 121 over 4. Square rooting both sides. Remember, we square root. There will be a plus minus because we're talking about two possible solutions. Remember that, not to miss plus minus. And luckily, x plus 1/2. Right, the square and the square root cancel each other out. Whatever's inside comes out clean. Is equal to plus minus. Now, square root of 121. We don't know what 121 over 4 is, but we know the square root of 121 is 11, and the square root of 4 is 2, right? So that's good. So now, the first x is what? The first x, as a result, is subtracting 1/2 on both sides and keeping the positive. 11 over 2 minus 1/2. Or, minus 11 over 2 this time, minus 11 over 2, because we use the plus, now we use the minus, minus 1/2. So as a result, what is that equal to? x1 is equal to 10 over 2, which is 5. And the second solution is minus 11 to minus 1 is minus 12 over 2, that's minus 6. Now guess what? You see it's the same solution. It's the same solution that we found using the factoring method. Now let's try the quadratic formula and see the beauty of that. So we definitely know the discriminant will be positive. It will not be 0, it will not be negative, right? It will not be negative for this, the discriminant will not be negative because we have solutions. It will not be 0 because we have two solutions, right? So the plus minus will matter, right? So under the radical, there will be the positive discriminant. B squared minus 4ac will be positive, right? This part here, that will be positive. Okay, so let's take a look at that. So x is equal to, well, let's follow this formula that I've written already. So let's see what the b is. Well, let's write the b's first. So let's see. So a is equal to 1, b is equal to the coefficient of x, and then c is equal to negative 30. Don't forget that the minus here is part of that c. Don't just put c for the don't just put 30 for the c, because that would be wrong. You will get a completely wrong answer, a different answer. So a is equal to 1, b is equal to 1, c is equal to negative 30. So x is equal to minus b, so minus 1 plus minus b squared, so that's 1 squared, minus 4 times 1 times negative 30 divided by twice the value of 1. So that's equal to minus 1 plus minus. Now what do we have here? Negative 30 times negative 4 is the same thing as 30 times 4. That's 120. 120 plus 1 is 121 divided by 2. So x is equal to minus 1 plus minus radical 121 is 11 divided by 2. Okay? So as a result, you see it's the same thing. x1 is equal to negative 1/2 plus 11 1/2. That's 10 over 2, which is 5. And the second solution is going to be negative 1/2 minus 11 over 2. That's negative 12 over 2, which is negative 6. Right? So that's good. So as you can see, 3 different methods. You know when to use which. You know what the quadratic formula parts mean. Again, the discriminant, check the discriminant. The discriminant will tell you if it's positive, you will have 2 solutions. If it's 0, you will have 1 solution, because plus minus will not matter. There will be only minus b over twice a, 1 solution. If the b squared minus 4ac is less than 0, bingo, no solution. We didn't have no solution in this video, right? We didn't have any examples with no solutions. But you realize now, when there's no solution, definitely you will not be able to factor, for sure. But even when there is solution, you may still not be able to factor, right? Because if there's a radical, completing the square or quadratic formula will yield you the solutions with those radicals. If there's no solutions, none of these 3 methods will give you anything, right? And try to do it for fun. Try to complete the square for fun and see if it's possible to have a solution when there should be none. And I guarantee you, what you're going to have when you try to complete the square and there's no solution, you will probably have negative result here. You will have a negative result here, for example, and when you square root, you cannot square root the negative result, right? So plus minus won't matter because inside you cannot have a negative, right? So I think that would be the case. But try it out for fun and see where it is that you have to stop completing the square and saying, oh, wait, I should stop. It's not going to work. There's no solution, right? So do this for fun, and I hope this was a lot of fun too, right? Because this is so much fun for me. I'm just having a great time showing you this, and I hope it was useful to you too. So thanks for watching, and see you in the next videos of mine.